In this video, we will discuss concurrent lines, point of concurrency, and the circumcenter of a triangle. When three or more lines intersect at a common point, so three or more lines intersect at one point, the lines are going to be called concurrent lines. The point where the concurrent lines intersect is called a point of concurrency. So if we look at this triangle, we have three lines here that all intersect at point P. Now a triangle is special because it has three perpendicular bisectors that are current lines. So you can see these are perpendicular bisectors because they're perpendicular, and they separate the segment into two equal sides. The point of concurrency of the perpendicular bisectors is called a circumcenter. So for a triangle, our point of concurrency here at point P is going to be called a circumcenter. So the perpendicular bisectors of a triangle intersect at a point called the circumcenter that is equidistant. So this is the key word, equidistant from the vertices of the triangle. So if it's equidistant, PB is going to equal PA is going to equal PC. The circumcenter can be on the interior in an acute triangle, the exterior in an obtuse triangle, and right on the hypotenuse of a right triangle. To prove the circumcenter theorem, we can take three segments, PD, PF, and PE. So PD, PF, and PE that are perpendicular bisectors of AB, AC, and BC, so the sides of the triangle respectively, and we want to prove that AP equals CP equals BP. So since P lies on the perpendicular bisector of AC, so on this line right here lies P, we know this is going to equal this because that is the definition of equidistant, and our perpendicular bisectors are going to have a circumcenter that is equidistant from the vertices. So we know that AP equals CP, and then we can also see that the perpendicular bisector of BC, so this line right here, also contains point P, and by definition, we know that it's going to be point P is going to be equidistant from the vertices, so BP is also going to equal PC. So since AP equals PC and PC equals BP, then by the transitive property we can say that they are all equal to each other. Let's take a look at an example here. So in this example, we want to look at a stove S, a sink K, and a refrigerator R. And it tells us to find the location for the center of an island workstation, so it's the same distance from these 3 points. So what we could do is we could draw the perpendicular bisectors of this triangle. So perpendicular bisectors, right, it's going to go through the middle so that these two are equal through the middle of this one. So these two are equal, and through the middle here, and all are going to be perpendicular so that this side is equal to this side. And by the circumcenter theorem, a point equidistant from 3 points using the perpendicular bisectors of the triangle formed by those points is going to give us these equidistant lines here. So this point is going to be equidistant from the three vertices of the triangle.